right, we are still on 4.8, analyzing the graphs of polynomial functions. This is video number 3. In this video, we're going to graph each function, identify the x-intercepts, and the points where the local maximums and local minimums occur. We want to also determine the intervals for which each function is increasing and decreasing. So we need to start with vocabulary. So a local maximum, it is the y-coordinate of a turning point of the function when the point is higher than all the nearby points. So if we look at this, a local max will be at the top of, if I just look at just these points in here, kind of get rid of everything else, that is the highest point between all those other points. Okay, so a local minimum is the y-coordinate of the turning point of the function when the point is lower than all the nearest. So it's coming down, and it's where it's changing to go back up. Okay, that's a bottom. I like to think of these as like this is a peak and this is a valley. The bottom of the valley is the local min, and the top of the peak is the maximum. Okay, and it's called local because this graph actually goes on to infinity, so its maximum is actually is infinity, and its minimum is actually negative infinity. That's why we call them local. It's like what we can see in the graph. All right, so we do need to figure out or learn a little core concepts here. So talking about these turning points, which those max and mins, okay? The graph of every polynomial function of degree n has at most n minus 1 turning points. So if it is a cubic polynomial, which means degree of 3, at most it has that 3 minus 1 turning point, so 2 turning points at most. Doesn't have to have 2 turning points. It could have 1 or 0. And then same thing with, if it was a polynomial of degree 6, it would have 5 at most turning points. So if a polynomial function of degree n has n distinct real zeros, so if its degree is 6 and it has 6 real zeros, which means it crosses that x-axis 6 times or touches the x-axis 6 times, then its graph has exactly n minus 1 turning points, so 5 turning points, okay? So you wouldn't say at most. If it has the same number of real zeros as it has the degree, you will have that degree minus 1 turning points. All right, so let's dive right in with number 5 in the notes. Okay, now this is a cubic polynomial, and we want to graph it and determine the max, the min, those local points, and then we want where it is increasing and decreasing, and those x-intercepts. So let's graph this function first. All right, so I'm going to use the calculator and just get a table quickly, okay? So if I type this function in, and I get a table, I need to be sure I'm on my table here. So -2 is off my table. I'm going to cover up my table here for a second, or my graph for a second. So I'm going to get the values -2, -20, -1, -6, 0, -2, 1, -2, 2, 0, 3, 10, and that's off my graph. And it just keeps getting farther off my graph. So that's all I'm going to fit. Well, yeah, because 310 is already off my graph. So I can plot these points. So at -2, -20, I'm way off my graph, way down low. That's not even a point on my graph. I'm just kind of putting a note to myself there that it's going off the graph down there. Okay. Then -1, -6, 0, -2, 1, -2, 2, 0, and 3, 10. Actually, I can get a point. It's just up there. Okay. Now, I want to go ahead and graph this, but I'm not quite sure like how some of my curves are. So I'm going to go to my graph so I can connect my points the best way possible. And see how it barely bumps up right there. Okay. So I'm going to come from down below barely kind of comes over and up. Beautiful. All right. So I can see I'm going to have a max somewhere in here. I am going to have a min somewhere in there because it does dip just a little. So my power is 3, which means 3 minus 1 is 2. So at most, I can have 2 turning points. So 2 max mins total. So let's determine our max. Now this is local max, okay? It's not, obviously its max goes on forever. So on the calculator, if I go to calc, it can find a max for you. So I'm going to push number 4. And around there is where I want. So to be left of it, I'm just going to go, I know I want somewhere over here. And then I'm going to go past it to where it looks like it's starting to go down again. And push enter, and your guess, you don't have to put 1, just push enter again. And it tells me when x is 1/3, y is at its max. So the max would be a negative 1.85. Okay. So the min, the calculator will also tell me what that is. So if I go to calc, the min is number 3. Left bound, I want to be, well, anywhere in here. Okay, enter. I just have to be higher than that min point on the left side of it, and I need to be higher than the min point on the right side, and then for my guess I just push enter, and it tells me at almost 1 y is negative 2. Okay, so I have my max and min. So if we go back to our directions, it said graph the function. We just did that. We didn't identify the x-intercepts, but we did identify the max and mins. So let's go back and identify the x-intercepts. Looks to me like there is only one of them. And we already know when y is 0, we're at 2. So you could say the x-intercept is at 2, or if it asks for a point, that would be 0.20. Okay, and then it wants the intervals for which each function is increasing or decreasing. So we need to look at this graph, and from left to right, I'm going to draw arrows determining if it's going up or down. So from left to right here, it is going up as it goes to the right, hits that turning point, and then it's going to go down to the minimum, and then it's going to go up to the left. That's a really bad arrow. I don't know what was going on there. Okay. And that's how I'd get my graph. If I were to draw this the way when I connected my dots, I went up, a little bit down, then I went up. Okay. Down is decreasing. The ups are increasing. Whoops, increasing. Can't write. So I know I have 2 increasing intervals and 1 decreasing interval. So if I write my increasing first, so I know what the y value of that max was. I really kind of need the x value because increasing and decreasing is talking about from left to right. So it's talking about the x values. So if we come back to the calculator before it falls asleep, well, I know this one, my min here was at well, it's basically 1.9 rounds to 1.0 or whatever, negative 2. And I'm going to go back and find that other one real quick because I should have wrote this down the first time. So I'm going to go past it. All right. So this max, that max point here was at 0.3 to negative 1.85. Oh, and actually to be clear, I think it's going to want 2 decimal places. So let's put a 0.33. Okay? All right, so now I have that. So for the x values, as it's coming from the left, it goes forever. That is an arrow at the end of this. So it goes from negative infinity to 0.33, which means x is going to be less than 0.33. If you wrote it in interval notation would have been negative infinity to 0.33, and it doesn't equal that, okay? Because it's not increasing at that max and min. Big Ideas just wants you to write it like this. And then it's also increasing again after it hits that minimum. So the x value of that minimum is 1. And I can't even write. So when x is greater than 1, because it's going forever, it is increasing. So if I were to write this, it's going to be 1 to infinity. That's how I'd write it in interval notation. But like I said, this is how Big Ideas wants it. So decreasing is in between these 2 points. So I know the left point is when x is 0.33 and the right point is when x is 1. So I can just put that is less than x and that's less than 1. Alright, I'm reusing a graph because I don't have another graph to use. So I need to, looking at this equation, I know that I have a y-intercept of -2. So I can actually put that on my graph right there. Happens to be on the same spot. Just ignore these other 2 dots. Okay? So when x is 0, I know that y is -2. Because if I plug in 0 all there, I get just -2 left. So that is all we can determine by just looking at the equation. So I plug the equation into my calculator. Oh, and that's not even right. Helps if I plug it in correctly. Alright. There we go. Now I go to the table. And I'm way off the graph. At -2, I'm at 46. At -1, I'm at -2. I have 0, -2, 1, 4, 2, -2, 3, -14 is off my graph, but I'm going to keep going because this one's back on my graph. So 4, -2, and then 5, 88. And then it looks like it just keeps going up and up and up. Okay. Alright, so I'm going to plot what I can. -2, 46 is way up off my graph. -1, -2. Again, forget that little thing right there. It's not on my graph. 0, -2 is already graphed. 1, 4. That one's not there. Okay. 2, -2. 3, -14. And even though it's not to scale, that's not as low as it's supposed to go, I am going to put a point there because it does need to come back up to 4, -2. And then 588 is way off my graph, okay? Alright, so if I look at this and I actually graph it, okay, so here's my graph. And now I'm going to connect my points so they look kind of similar to this. And I really wanted to look right here because these points are right next to each other. But if you look, it's really skinny and doesn't just barely go down. It actually goes down almost 3 units. So I'm glad I looked. So I come down here and it goes down past this almost 3 units worth. Kind of comes like this way down here. It actually went lower than that, but it doesn't fit on my graph. So since my degree is 4, I actually do have 4 zeros, which means I'm going to have 3 turning points. And I do. 1, 2, 3. All right. So I'm going to, when I drew it, I came from down here. So I'm coming down. I hit my turning point right here. And then I go up, hit this turning point, and then I go down as I was drawing, hit a turning point, and I go up. Alright, every up arrow is increasing, every down arrow is decreasing. So let's find some points here. Well, let's first find our x-intercepts. Alright, I just want these. They have nothing to do with increasing, decreasing, or that kind of thing. So I'm going to use the calculators because those don't go through exact points. So on your calculator, whoops, if you push second calc, we want number 2. And if we list them from left to right, I'm going left of this one, and I go for right bound, I go right and push enter. Enter for your guess. And I get that x is at a -1.11. Now I want the next one over, so second 0. Okay, that's between the 2 zeros, and then I go past it. Enter, enter. And I get 0.24. Okay, and then find the next one. Oops, that's not the right thing. Hold on. Okay, go between them, go past it, push enter twice. All right, 1.82. If you're using Desmos, you can actually just click on those, just so you know that. All right, calc. The only problem is with Desmos is you can't use it in class on a test. So, all right. So I'm going between them, I push enter, and I go past it, and I push enter twice, and I get 4.05. 1, 2, 3, 4. And those are listed in order from the smallest x value to the biggest. All right. So now we want the max and mins. So let's start with the max. This is a min because it's at a bottom, it's in a valley. Then it hit a peak. So this will be a max, and I want this point. And then this was a min. So I only have one max point here. So let's have the calculator tell me what it is by going to max. I need to be on the left side of that mountain. Push enter, and then I need to be on the right side of that mountain. Push enter twice. And it tells me the min value is always the y value. So if we round this, it's 4.04. Okay, but we do need that x value. So I'm going to write it over here. It's 1.07. The y value was 4.04. I'm not going to put parentheses before I do that again. Didn't have room. All right. Now we need our mins. Okay, and I do have two of those. I had two valleys. So let's find this one first by going second calc. I want number 3. That's a minimum. So I want to be on the left side of that valley, push enter, and then go to the right side, push enter twice. And it tells me this point is a negative 0.57, comma, negative 4.88. When I round that, that's what I get. So this is a negative 4.88, because it's the y value. And now I need to find this other valley that's right here. So second calc. Even though it's not in my picture, I can still find the minimum. So I need to go to the right side of just that valley. So enter there. Then I'm sorry, the left side of just that valley. Then I go to the right side, enter twice. And I get that this is 3.25, comma, negative 14.95. So this is 14.95. All right, so I found the x-intercepts. I found the local max and min. Now I need the intervals for which it is increasing and decreasing. So increasing is wherever I had arrows going up. And if you look, this arrow going up is between 2 points. And we just want these x values. So it's increasing, negative 0.57 is less than x, because that's the one on the left. And the one on the right is 1.07. So x is greater than negative 0.57 but less than 1.07. And then I have another up arrow here when x gets bigger than 3.25. So x needs to be greater than 3.25. And then for decreasing, it's everywhere I have down arrows. So let's start on the left side. It's coming from infinity down to when x is negative 0.75. So x is less than negative 0.75. Then this down arrow comes between when x is 1.07 and 3.25 because it went down right here. So if I work from left to right, it's 1.07 is less than x, which is less than 3.25. Now you can go to your practice and do 23, 24, 26, and 29.